welcome to this session. In today's session, we are looking at prime factorization. Prime factorization is the process of expressing a composite number as a product of its prime factors. A composite number is a number with more than two factors. So if we are to express this number as a product of its prime factors, we have to decompose it. Then a prime number is a number that has only two factors, that is 1 and itself. So if we are to prime factorize a number, it means that we are going to express it as a product of its prime factors. For instance, in example 2, where we are told to express 30 as a product of its prime factors, we are going to divide 30 by its dividers using the ladder method, and we shall multiply the divisors. Or we list the factors of 30 and we choose the prime numbers among the factors, and they are those ones that we shall use in dividing 30. So 30 is expressed as 2 times 3 times 5. That is how we shall express 30 as a product of its prime factors. If we continue to example 2, we are told to express 220 as a product of its prime factors. Still, we shall decompose 220. We can either use the ladder method or the factor tree method. So if we use the factor tree method, we shall start with 2. We divide 220 by 2 to get 110, which we still divide by 2 to get 55, and 55 is divided by 5 to get 11. 11 by 11 you get 1. So 220 is written as 2 power 2 times 5 times 11. Why do we have 2 power 2? It is because 2 has appeared twice. So our final answer will be 2 squared times 5 times 11. That is how we express 220 as a product of its prime factors. So after looking at how we express composite numbers as products of their prime factors, we now want to look at factors and multiples. Factors are numbers you multiply to get a certain number. For instance, if we look at factors of 6, to get 6 we multiply 2 by 3. So 2 and 3 are the factors of 6. When we come to multiples, multiples are the results you get when you multiply a number by another natural number. For instance, if you multiply 6 by 2, you get 12. So 12 is the multiple of 6 and 2. So those are factors and multiples. Now we are going to look at the highest common factor of 2 or more numbers. It means the largest factor that is common to all the numbers. For instance, if we look at 8 and 12, we are going to look for the highest common factor of 8 and 12. So we mean that largest number that can divide 8 and 12. Automatically that is a 4. The 4 can divide 8 to get a 2, and also to divide 12 to get a 3. So 4 becomes the highest common factor. In our example 4, we are told to find the highest common factor of 18 and 30. We can do this in two different ways. We can first of all list the factors of 18 and 30, then we pick the highest or the largest, or we can even use the ladder method. But when you are using the ladder method, we shall use common numbers, a number that can divide all the given numbers. We shall come to that. So when we are listing factors, we know that 18 is the same as 2 times 3 times 3. Or when you factorize 18, you get 2 times 3 times 3, which is 2 times 9 to give us 18. Then 30 is 2 times 3 times 5. So meaning that when you look at the common values in 18 and 30 is a 2 and a 3. So we multiply those common values to get 6 as the highest common factor. Then in example 5 is where we shall use the ladder method. Example 5 requires us to find the highest common factor of 80, 120, and 280. So we shall use the ladder method, but when we are dividing, we make sure that the number divided is dividing all the 3. It should not divide 1 or 2. It should divide all the 3 because it is a common factor. So 2 can divide all the 3 to give us 40, 60, and 140. Still a 2 can divide to give us 20, 30, and 70. Then a 5 divides all the 3 to give us 2, 3, and 7. So to get the highest common factor, we shall multiply the divisors. That is 2 times 2 times 2 times 5, which is 40, meaning that 40 can divide all these 3 numbers. That is 80 by 40, you get 2. 120 by 40, you get 3. And 280 by 40, you get 7. So that is how we use the ladder method to find the highest common factor. Then we come to how to find the lowest common multiple. The other one was highest common factor. This one is lowest common multiple. We've defined a multiple as the result you get after multiplying two numbers. For instance, when we multiply 2 times 3, we get 6. So 6 is a multiple of 2 and also a multiple of 3. But In this case, we are looking for the lowest common multiple, that smallest number that is common to all these numbers given. In example 6, we are told to find the lowest common multiple of 18 and 30, meaning they want us to get the smallest number that is common between 18 and 30, or which can be divided by 18 and 30. That is probably 90. But how do we get this 90? We still have two methods. We can express these two numbers as a product of their prime factors. That is 18 is 2 times 3 times 3, which is the same as 2 times 3 squared. Then 30 is 2 times 3 times 5. So when we are looking for the LCM, we shall multiply the 2, which is common, times the 3 squared times the 5. Now, you may ask, why are we using 3 squared and not 3? Because we are looking for the multiple. And probably that multiple is 90. Meaning that the lowest number that can be divided by 18 and 30 is 90. Then example 7 gives us the other method, that is the ladder method. In the ladder method, we list these numbers and start dividing them, but it is not the way like we do in the highest common factor. Remember, for the highest common factor, we will say that when dividing, the number dividing should divide all the 3 values. This time round it is not. This time our target is to reduce these numbers to 1 using any prime factor. So if we start with a 2, the 2 doesn't divide 5, neither divides 15, but it can divide 30. So that we get 15. And the next one will be 3, because the 3 can divide 15 to give us 5. And lastly, we get 5, which divides all the 3 to give us 1. And now, after reducing these values to 1, we multiply the divisors, which is a 2 times a 3 times a 5, to give us the LCM as 30. After looking at LCM and HCF, we also have the squares and square roots. A perfect square is a number whose square root is a whole number. For instance, the square root of 4 is 2. So 4 becomes a square, a perfect square. But the square root of 6 gives us a rational value. Therefore, that one is known as a surd. The square root of 6 is what we call a surd, because it gives us an irrational value. Then the square of a number means that number to power 2. If I have the square of a, it means that it is a power 2. and the square root of a number is the same as that number to power half. If we have the square root of 4 is the same as 4 power a half, which gives us a 2. How do we get a 2? Remember that 4 is 2 squared. So the square will go with a half to remain with a 2. Let us look at examples. Example 8 requires us to find the square root of 256 without using a calculator. How shall we do this? We shall factorize 256 and express it as a product of its prime factors, which gives us 2 power 8. So if we get 2 power 8, but remember we are looking for square root, so the square root of 256 is the same as the square root of 2 power 8. And therefore, remember we've said that the square root is the same as power a half, meaning that we shall have 2 power 8 power half, and the a half reduces 8 to 4. Therefore, we shall have 2 power 4, which is 16. Still, we shall continue. We have cubes and cube roots. A perfect cube is a number whose cube root is a whole number. For instance, the cube root of 8 is a 2. So, cube root of 8 is a perfect cube. But the cube root of 10 will give us an irrational number. And the cube of a number literally means that number to power 3. So if any number is to power 3, then it is a cube. However, the cube root of a number is the same as that number to power a third. Just like we have seen the square root, which was to power half. So cube root is to power a third, fourth root is to power a quarter, fifth root is to power a fifth, and so on. Still, we can find the cube root of a number without using a calculator. Let us look at example 10. In example 10, we are told to find the cube root of 3,375 without using a calculator. So what we do, we factorize this and express it as product of its prime factors, which gives us 3 power 3 times 5 power 3. But remember, we've said that cube root is the same as power a third. So we can multiply 3 times 5 to get 15 and give it a common power so that we get 15 power 3. But remember, cube root is to power a third. So the a third will go with the power 3 to remain with 15 as our answer.